can you give us a little bit of a brief description of the structural framing for this project?
Yes, so I think that one will be best if the structure engineers go in on that. Schalk, would you want to maybe?
Yeah, I'll take the lead on that. So we've predominantly got the project comprises of two buildings. So we've got the headquarters building for Capitec. It's predominantly a concrete frame structure and sort of let's call it a figure 8 compressed skew type configuration. So, and then we've got structural steel components in the main structure. Basically, if we walk from the outside of the building in, we've got a fairly elaborate entrance canopy structure. And then inside the building, we've got a host of infill bridges and infill floor that was done in composite construction. And then we've got a fairly conventional steel roof overhead with large roof lights. I'm not sure if we're really covering the parking structure, but the parking structure it's got a composite infill section that is supposed to be removable. And if we look at, let's say, the most unconventional part of the building was the infill sections, where we used the max steel the cellular beam configurations, and also an ultra shallow floor beam system, where we had limited headroom, limited structural depth, and we opted for a type of composite structure to deal with vibrations, long spans, and to try and make it work. I think we've got, over the entrance area, we've got an opening of in the order of 18 to 20 meters, and we've got a structural sort of office floor over it with steel composite beams spanning 13 meters roughly.
So I have enabled screen sharing for any of the participants. So if you've got some things that you'd like to share, then you're welcome to do so. I am just going to share my screen of the photos that were submitted for the entry. But if there's anything that you'd like to share, you are also welcome to do so.
Okay. No, I don't have anything in particular to share at this point, so I'll just talk through the photos.
Okay.
So what you see on screen there is the composite cellular beams used for the bridges, and the advantage of using a composite section, or composite type detail with in situ upstands on it, is that you actually gain a lot of stiffness out of it. So from a deflection point of view, it works well, but it also deals with the natural frequency of the structure itself. Because if you hear the word footbridges, you always there's lots of people who get it wrong with natural frequency, and then you've got a whole host of problems, and it's very difficult to fix afterwards.
What were some of the challenges that you had with this aspect of the project, and how did you overcome them?
The biggest challenge basically was we had a problem with weight, and we had a problem with span lengths, and it's something that for a pure concrete structure, to span those lengths, you need depth. We didn't have it. So the only option basically was to go for a hybrid type setup, where we utilize the benefits of composite steel construction.
Great. So then, just in terms of I'm not sure if you'd be the right person to answer the fabrication and erection questions, but can you tell us a little bit about how that went?
Given how rough concrete construction can be, I think it went fairly well. We had a couple of issues in terms of levels and coordination details with reinforcing at the end supports, but in general it actually worked out okay. I think Donovan's probably the one who can probably fill in better, but from an engineering and sort of inspecting point of view from our side, it actually went surprisingly well. It could have gone a lot worse.
Donovan, do you perhaps want to?
I just want to add quickly onto that. So, as you know, we've been manufacturing cellular beams for up to I think 15 years or so. But a challenge that we didn't foresee, and this was which affected Donovan from a fabrication point of view, was specifically on the ultra shallow floor beams, as this is probably, I think, one of the first projects we've worked on where the engineers were quite innovative in utilizing it. So I remember I think the top section size was a 305, 305, 137, and the bottom flange was a 457, 191, 82. So both section sizes had different thicknesses. So an issue we had encountered just from a manufacturing point of view was, we didn't anticipate assembly taking quite long, because we needed to ensure that when we're conducting the full penetration welds on the web, everything was done in accordance. So that was just a delay in terms of lead time, because we had given Donovan a set lead time that, look, you'll have all your beams delivered, manufactured, tested, everything by this particular date. However, the ultra shallow floor beams just took a bit longer, because we needed to ensure that they were done correctly. But in the end, all pulled through. But that was just an unforeseen challenge we saw, just in terms of underestimating the particular lead time.
Yeah, I think it's also a contributing factor is that we've got a smaller available section size to pick from. So if we went for the pure European-based design, we would have had a closer match on the webs, and it would have been a little bit easier in the manufacturing. Unfortunately, it's the South African way of doing things. We have to make a plan. So.
Donovan, do you want to perhaps just elaborate on the fabrication and erection?
Good morning, all. Yeah, just on Alex's review on the making the beams, we also had the issue with because we're using two T sections and they were quite offset. We had to utilize the beams quite well, because usually when you split the T sections, you split them in the middle, so they form a uniform beam. So we juggle the beams around to get there, because the hole was off center it had to be center of in the beam, but because we used two different sections, we had to use the off center we had to be cut off center, if that makes sense. But besides that, I mean, the help from Max Steel that they provided us with their experience helped quite a lot, because we initially ordered the beams as per the engineer schedule, but they weren't available. So we had to go back and forth, and with Skalk and them, and with Max Steel contribution, we utilized the current sections we had quite nicely to work for the design. The manufacturing process on the cellular beams wasn't in our hands. I mean, Max Steel provided them to us. We just had to fill in the blanks. There was part of the beams that we had to close the cellular holes on the ends, but the installation of it is quite simple. The difficult part for us in this installation was the fact that we had to the brackets was quite intense, was quite big and bulky, and with the shear studs that we had to connect to them, and the rebar configuration, we struggled to get it in. So that was probably the most difficult part, to get them on the right height and then in the correct positions. And because the bridges was on a diagonals, not parallel or square to the grid lines, the setting out was quite crucial, and they were casting the concrete on different stages. So there was never quite a straight line that we can span across to see if the brackets would line up. But luckily, they did. There was some small tolerances we gave ourselves, but at the end it all worked out. So it was quite a simple installation. As they always say, measure twice and install once. So it worked for us.
Yeah. Emmanuel, John, do you have any questions?
Yeah, actually, I have a question. I don't know who should address it. It might be the engineer, or it might be Axel. I saw a number of props where the concrete pour or the decking goes. Was there no way to avoid using props as in what we would do in general construction? That was the first question. Second one is relating to the connection between the girders and the building. Is one a slotted connection for movement, or are they both fixed? Yeah.
Okay, let's tackle the propping first. We had to go for prop construction on the really long beams because of deflection issues. We tried to control the final deflection. Those beams are on order of 13 meters, so it is quite tricky. The other complication we had is we don't get the same decking profiles that they get in Europe, where you have the kingspan decks that are quite deep and quite stiff. So we ended up with the, what's the other local one? Not the
Bond deck.
Not the bond deck one. Oh, no, I forgot the name. But there's another composite deck manufacturer, but the sheet profile is fairly thin. So you end up where you can't do unpropped construction on the sheets. So it's got an internal rib structure. So we managed to space the beams so it can get away from prop construction on the sheets. But due to the long-term deflection and final deflection values, we ended up with prop beam construction. It was a little bit tricky because the contractor worked from the top down for construction sequencing as well. So we erected all the beams bottom up, and then the casting was done top down. And then, yeah, the end connections, we had a slotted hole. So those bridges actually float between the section, between the portions of the building.
Was the decking void-con?
Yeah, it was void-con, yeah.
Did I understand Donovan correctly? They were involved in putting in or siting the connections that were cast into the concrete, not the civil contractor. Is that right?
Well, they supplied them on behalf and manufactured them on behalf of the main contractor, but I think Donovan and them were also involved in installing in the placement. It was quite an involved setup because we've got a fairly thin floor configuration, picking up those heavy point loads at the edges. So you end up in a detail where you've got loads of congested reinforcing, shear studs to try and transfer loads between the concrete and the steel bracket. You still need to allow some sort of float. And then, yeah, and the fact that they're skew complicated matters in some instances quite a bit.
Did they get it right? Well, obviously they did, because it's
still standing. So yeah, they got it right.
Okay, but it must have been a bit of a sweat.
It was tricky. There were quite a couple of arguments and heated discussions getting them all in, especially on the breakneck pace that the main contractor put up the concrete frame.
Yeah.
I think they were probably at some point almost 3 months ahead of schedule on the concrete frame. So some of our information date on the concrete structure moved up almost 3 months in instances. So
yeah, at the beginning stages, when the concrete structure was ahead, they've put stop ends in where we had the brackets, because the brackets weren't on site yet. So you just imagine when you've got the Y30s on the edges, top and bottom steel, and you've got to get these brackets with, I think each connection bracket had maybe 30 shear studs on them in all directions. So yeah, I wanted to walk away plenty of times and said, this is your you're doing, please help here. But at the end, I mean, they just I wanted to put them in to make sure that they're right, because at the end of the day, the contract's going to look at me and said it was my responsibility to make sure they were in the right place. So we battled the first few. It got easier towards the end, but yeah, it's not something that we haven't done before. So
hopefully, if it was your responsibility, you called the shots.
No, I did.
You did. Excellent.
I did.
Perfect. So how would you say that this project demonstrates the benefits of steel? Who wants to go first? Skulk.
Let's just say Peter got limited, well, he got the headroom he wanted, and we got the clearance that he wanted as well in the foyer. So it is quite impressive if you actually look at the clear spans. And also the benefits of the steel setup is that we managed to hide a lot of the services in those bridges because we've got that clear path between the beams. So there's a couple of areas where it got very tight, but we managed to get all the services in and the clearance that the architect and the client wanted.
Excellent. Peter, have you got anything to add there?
How complicated it all was. I thought it was going to be so simple. It
can be if it's, you know, if if you don't have a very fast civil contractor, I think
Yeah.
you've got the information in time, can be, but I
think,
appreciate the heartache.
yeah, I think the result is for a very elegant structure. Actually, I think it's graceful. It's very simple. Or rather, it's not simple, but it looks simple and dynamic when you look at it. And but underneath all that, there's a lot of complexity, which is led to what you see as a simple solution, but actually it wasn't. And hats off to the engineers and all the fabricators. I mean, it's the first time I'm actually seeing Donovan. So well done for what you've achieved. And I think also the span, the Frezi bars and all that as well, and across the entrance, particularly across the entrance there where that big span is, where quite late on in the day we said, oh, we don't want any columns in this space, please, which I think presented Scott with a bit of a headache. And so well done for resolving that.
Yeah, we ended up using the front of the building on the edge of the entrance actually all hangs from massive beams at roof level. So we've got a sort of it's a real hybrid structure. So we've got the composite infill floors, we've got a transfer beam at roof level with steel hangers, high strength steel hangers, picking up the outer perimeter of the building.
Right.
Just to further elaborate, on the same points that have already been made, the entire structure is just a good example of showing, the marriage between, the two widely most used construction materials of concrete and steel, and how well they work together. Especially with, the innovative use of where the architect needed a shallow ceiling and utilizing the ultra shallow floor beam as a flat slab solution to get that to work. Two main points in looking at it.
Great.
Actually, one thing to say: the height constraint was very real. We had very limited height to achieve this building within, and to get all the accommodation that the client needed within. I think it was a 11 or 16 meter height constraint, and of course with the economics of not wanting to excavate too much in order to put a basement for car parking in, and then you've got that limitation at the bottom and another limitation at the top, then you've got 3 levels within that. So yeah, I think the hybrid structure and the way that was achieved, and it did put a lot of pressure on services, and also getting those services articulated through all the structure was also a job well done by the team.
Good. Donovan, what are you most proud of on this project as a fabricator?
Probably the biggest one is probably that everything fitted after all. No, it's usually, it's usually the timeline. Because of the concrete structure was so far ahead, we couldn't slip on supplying the steel. And because of the lead time with the castellated beams, it's not something that we could get and then manufacture to speed up the time. We had to sit and wait for the beams. So we had to do our part to get the structure on time. And that includes the roof, which was a whole nother ball game. But that was probably, being on time is always a good feeling when you finish a project on time. The fact that you can't see any of the steel afterwards is something only we know. But it's a proud feeling when you go through the arithmetics of building something and having a stamp on there. So that's a pretty cool thing to be part of. But yeah, it's always the challenges of trying to do the right thing in a question when there's pressure of time, and making sure your guys on site doesn't make any mistakes when the installation happens, especially safety wise. So I think overall it was a pretty awesome project for LRJ Steel to be involved in. No serious time delays or safety issues regarding the installation. The engineers are happy, so we are happy. The client's happy, we are happy.
Good. Emmanuel, any questions or comments before we get to final comments from the team?
How does the bridge perform in terms of vibration?
Well, for the floor sections, 13 meters, we're well just at above the limit of 4 hertz, and the bridges were designed to function at, I think we generally above 6 hertz is okay, but we're above 8. So that generally is acceptable for floors. Yeah, it's not as if you're going to have rhythmic activities in an office environment necessarily. So,
have you guys actually walked on the bridge yet?
We walk them, jump them,
okay.
Groups of people try to excite them. You can't feel it. So
how thick is that topping on that deck, on the VoidCon deck?
The VoidCon deck, I think, was about 75 topping. Okay. 75 to 100.
So there's quite a bit of there's quite a bit of weight also there.
Yeah. So you need the weight. If you go too light, you're stuffed. On the bridges, the biggest advantage is probably we've gone for conventional concrete upstands on the deck, so that provide quite a nice stiffening effect on those floors as well.
Yeah,
and the added weight.
Peter, is there anything that you'd like to add in closing? You're on mute.
No, just that one of the questions was, what are we most proud of? I think one of the things I'm most proud of is, in terms of this award, is really the interior and what the contribution the structure has made, and the hybrid structures that the team put together has enabled what is quite a dynamic, sort of visually engaging some space, which the client wanted. That was their brief. They wanted something very simple. Their brand is about simplicity. Their brand colors are kind of, well, like 80% white in their brand coloring. So that was also brought through into the building. So when you go into the structure and into the building, it speaks of the brand. So it speaks of the Capitec brand. And I think also, interestingly, I think post-COVID, we've talked a lot, the client wanted a very agile working environment and a structure that would enable them to change in the future. And the building's already enabled them to change even before they've occupied it. So even before they were fully occupying the building, they've already been able to make changes, to use the bridges and all the various staircases that span the atrium. They've got 3 entrance points in the building as well, so they can come and go, and they can compartmentalize. Even though it's an open plan space, it's very generous, really, and very lofty. So there's a lot of good quality air in there. So in a post-COVID sort of world, I think it's worked very well. So the interiors, I think, has come up superbly well. Particularly, so I think it's all those bridges and the staircases that Scott and the team have wrangled with has really enabled the client going forward.
Axel, anything you want to add? We've probably got about 10 minutes or so just to wrap up, so go for it.
Yeah, no, with regards to especially this, nomination, since I've started, I took over nominating the projects from Max Steel's point of view. As a young engineer, initially I had always thought, the structures must be predominantly steel and all of that. But what I enjoy about this project, and similar to the one from last year, is how it showcases how steel can be complementary to the structure. Composite, working in hybrid with concrete, and specifically what it does, for floor applications, which is primarily a focus I'm trying to push with regards to cellular beams. And I think mostly just, the first project that we've actually had in, I think, probably the history of the Steel Awards, where the engineers were very innovative in utilizing ultra shallow floor beams. So I do hope it's a project where other engineers can look and see, oh, okay, these guys, they went with this particular solution. Can it also entice us and inspire us to also be, innovative in our designs going forward? So I'm hoping it is a project that gets a lot of engineers and architects just thinking about, the way they go about their designs innovatively, especially when marrying the two construction materials of concrete and steel.
Donovan, anything you'd like to add in closing before I ask the judges if they've got any other questions?
Not specifically, but yeah, it's always a proud thing to be. This is probably from LRJ Steel. We've had numerous nominations at the Steel Awards on previous years, and I think we've probably got the best chance to showcase something with Capitec. It's something that's not very visible, but the way they've incorporated the steel in the concrete, I think, is quite an attribute to design aspects. Yeah, so my feeling is quite good with what we've done, and thanks to Max Steel and to Skalk and his team and everybody who was involved. It was good to be part of the project like that.
Good. John, do you have any final questions or comments?
Yeah, I'm just looking at some of those pictures there, and the focus has been on the bridge there. But there seems to be a heck of a lot of steel in this project, more than we focused on originally. The entry was for the bridges, eh?
It was predominantly pushed by Max Steel to get more exposure for the use of the composite sections, but there's a fair amount of other steel in the project. So the entrance canopy, as I mentioned, quite a bit of an interesting one. It stands on these two big V columns. The entire thing is floating. It actually doesn't look like it's supposed to work, but if you actually check the member sizes, they're quite substantial. And then the infill structure on the parking structure is probably a bit of a novel idea. The request from the client was to have a building that is convertible from an office building to, actually from a parking structure to an office building in future. So if you look at the building shape and form, it doesn't look like a parking structure. It's completely shaped in 3D, leaning sides, curved. And then on the inside, we've got a ramp structure that actually provides vertical circulation for cars. And it's done in a conventional composite type setup so that it can be removed afterwards. Yeah, and hopefully quite a bit of the steel is salvageable. But yeah, I think that's also a little bit different. Not often that you design something like that to be convertible. And then once again, doing something that you can take out where composite construction or steel construction works best. And then the roof is probably more conventional. It's a bit more tricky due to the shape. It's sort of a flattened Z configuration if you look at it in simple terms, but it's got these 4 massive pods in them for roof lights. In terms of the design, actually, it complicates the detailing more than the design. Because you've got so many angles and planes to work with and different kinds of connections. So it's a bit more tricky to line up all the finishes, the waterproofing, the connection details, and then glass connections as well. So yeah. So in the end, from my side, it's just the nicest thing about the building is to see the actual clear space achieved.
Yes.
That's normally the nicest thing you walk in, it sort of doesn't feel right, or it's like, how is this done? Because that sense of space is something that's not always that easy to achieve. And that's also, it's sort of, you stand there in awe, okay, we managed to do this. So.
Great. Emmanuel, any final comments or questions from you?
No, just curious about the rest of the composite floors. So were those bond deck, or were they also
yeah, the bridges were bond deck because they span across the beams and sit proper above it. The parking structure is also a conventional bond deck. The only reason for using void con is because it's got a deeper rib profile.
Yeah.
So it allowed us to decrease the own weight of the concrete.
Yes.
Anything else, you would have ended up with a flat deck almost, and polystyrene void formers and everything, and
Yes.
that becomes a bit of a nightmare to work with.
Yes. Cool. No more questions. Nice project. Yeah.
Great,
Thanks,
super. So from my side, thank you very much to all the project team members and the judges for making yourselves available just to chat about your project, and all the best.
Thanks very much.
Super.
Thank
Thanks
you.
for the opportunity.
Thanks. Pleasure.
Thank you so
Thanks.
much. Denise, just one last thing.
Yes.
Because I know John did mention a particular focus on the composite, but I mean there is quite a lot of steel in the structure. Would you want more pictures of the structure?
You can send some more through on the other elements, and then we can just include that in the submission.
Okay, perfect.
Great. Okay, keep well, gents. Have a good day.
Thank you.
All right, thanks, Axel.
Okay.
Thank you.
Bye-bye.
Thank you.
Bye-bye.
Pleasure.